recording now for posterity. Cool. So first of all, do you guys have any questions about anything you've done this week or what have you? How's everything going at your end?
Going good.
Yeah? Everything making sense and slowly slotting into place?
Yep.
Okay, that's cool. What about you, Arena?
Oh, I just got back from a vacation, so nothing makes sense to me right now.
Okay, no problem. Okay, one of the things, what I'll go over today is FFilterExtension. There's a few FFilterExtension, one of these things that you'll probably will be dealing with a lot if you do, helps support people in the field. So, as you know, data comes in, we record it, produce our forecast, and spit data out again. All right. So FFilterExtension is the part that reads the data in. So clients will send us a file, and that can vary from sensible, nice CSV formats to stuff you just shake your head at going, what the hell is this? Quite seriously, I've seen some bizarre stuff come from people. And it's typically the more bizarre it is, the higher up the management chain the decision on the format has been made. But anyway, the customer's always right, and so we do our best to handle them. Often it's quite good if a client says, well, how do you want the data? It's quite good to go straight back to them and just say, look, a straight CSV file, date, time, load value, in standard time. And they'll go, oh, okay then. And if they can do that, great. But if not, it at least makes them think along those lines, right? At the end of the day, we'll take whatever file the client will give us and we'll read it in. And so that's what FFilterExtension, how this works. It's a fairly sort of straightforward program, really. So if I open up the main program.cs file, so we come in, and this will typically be called by control console or tester control. We'll fire it off, and typically it's just FFilter extension and then -T and then the task to do. And if I quickly switch to one of these, this, for example, for this specific one, INBRPL, which is an Indian client, this is what you'd have in the Tesla INI. And so the key one here is your type code 1, which is INBRPL, and then you break down the details of where the source file is and anything else like the archive folder and the ultimate output data table, which I've just called AAAA load act here. Obviously, you'd have a more sensible name, but I'm doing this because it's just going into a temporary database at the moment. So if I bring up properties here, so in my debug, I'm going to start this project and I'm going to pass in -T INBRPL load. And so if I go into the program.cs file, goes down here, it reads in the ini file as we normally do, sets all the stuff up for us, and then it says, have we got a switch -T? Yep, so that's our task name. And then a whole lot of guff you don't need to really worry about. And then we'll go run task name. Okay, so then that leaps down to this method. Couple of little housekeeping things you don't really have to worry about. You could always trace through this code if you wanted. But essentially, it's just going to switch on the type code here. So it turns it to upper. And so if you make your own type code, you'll be making your own one of these here. You make your own class, and then you put your own case in here as well. So I quickly search down here for INBRPL. Here, it's going to hit this point here, and it's going to say my exporter is going to be a new instance of this INBRPL object, and we just pass in the standard tags. Then it breaks out of here, and then where are we here? Then all it's going to do then is call read input on it. on the object that's created, okay? And then it's just going to bail out, essentially, because the object's going to take care of doing everything else and reporting any errors, etc. So if I go into this INBRPL class, the first thing I do is a couple of housekeeping things. So if I'm going to create a new one from scratch, it'll be listed under this import objects. So here's all the other objects for different clients and things like that. The first thing I'm going to do is probably just copy and paste one of these, right? Then rename it to something sensible. So, I would have copied and pasted something, and the first thing I did was rename the file INBRPL and rename the class to INBRPL, okay? And then what I do, another little housekeeping thing, is at the bottom of the file, just in a comment, I put an example of the file, because quite often if someone says, hey, this thing's not working anymore and the guy who wrote it's on holiday or whatever, you got to have somewhere to start, right? And if it's quite often it'll be very straightforward. You look at the test already file and it's pointing to a file, and you can see that file and you can open it up and use it. But it's quite nice just to spend a few seconds to give an example of what the file is. And as you can see here, it's a CSV file. It's got date, time slot, block, and load. Okay, and I know from the client that obviously this load column is what we're interested in. You can see here this date time. For some reason they've, this is coming from an Indian client, so really this column is identical. The date time is just the date. And then what we're actually kind of, I think, interested in here is the block number. So you see that goes up to 96 because it's quarter hourly. So we want to convert this into our standard format, which is date, time, load act. Okay, and so that's fairly straightforward, right? The thing is, this comes in as a XLS file, so this is why I want to show you this, because it'll show another little tool that makes life easy when we have a CSV file come in. So read input, so that's the function that's called from the main program, right? So we come in here, we grab a couple of things that we're interested in from the ini file. As you remember from up here, we want the source file, the archive folder, and the data table. And so we just grab those and chuck those into these variables. Then we convert the files, which will convert the Excel to a CSV, and then we just read in the resulting CSV. Okay. Now, this class also inherits from one called import base, and I'm just going to quickly go in here because this does a few other common things. For example, the constructor, what it does is it chucks in, like the test or any object that's passed into the member variable, the name of the tag, etc. The DB access object. It also pulls out a couple of other things that are quite often used, like the site type and the region ID if they happen to be in there. And it also contains a bunch of other methods. Now, if I just collapse to definitions here, so there's a bunch of different methods which some of the objects, will use. So, a bunch of common methods in here, but one of the sort of real key ones here is like the put table data methods. These ones here. So rather than calling put table data directly on the DB access object when we want to save into the database, we just call this one in the base class, because it does a couple of extra things for us. Mainly if we're reading in, say, forecast data, like a weather forecast, it'll put that data into rollback tables for us and things. So let's put table data. Once we finally do create our data table object, we'll go in here and this will put it in the database for us. Oh, sorry, I just had a phone call there. Let's put that on mute. But we'll go straight back to our main main file here, and we'll have a look what happens. So we've got convert files. If we go into this method, so this is the one that's going to convert the XLS to a CSV file, and you can see it's quite short because we've got this in the utils XLS to CSV that does the work for us. So we do a couple of sensible things. We check to make sure that the archive folder we're going to put it into exists, and we create it if it doesn't. We get the source folder and file name, we separate that out from the source file that's specified. And then we have a look in our source folder, and we grab all the file names that match, because we can see here our source file is a wildcard, star.xls, so it's going to say work on every XLS file in this folder here, right? And in fact, if I just press F5 to run this code, we can just trace through as well, which might make life even easier. So go in here, a folder exists. We say, right, here's from the source file we get the folder and the wildcard to look for. Then we get our list of file names and see temp attachments. Let's just come back as 0. Let me have a look here. See temp attachments. Yep, I'm just going to put a file in there for starters. So you can see here there's no file name, so it's going to just bail straight out. But I'll just put one in there, so if I run it again, convert files. So we've got a file name this time. We work out our CSV file. All I do is text CSV on the end, and then I just call this handy little utility XLS to CSV. So this does make our life easy. If we go in here and take a little look at it, you say what Excel file you want to use, the resulting CSV file, and then you can convert a sheet name or a sheet number. And so this just makes your life a heck of a lot easier. So you don't have to worry. Essentially, you just don't have to worry about the hassle of converting Excel files. You just call this method to do it all for you, and it just strips out all the guff in there and chucks it straight into a CSV file. Now let's see if I give you an example here. If I open up this XLS file, if it's going to open. And I'll just quickly show you what that looks like. So you can see here, this Excel file includes like graphs and stuff like that, which of course we're just not going to care about. And if I open up the resulting, where are we here? Open up the resulting CSV file, this is what it ends up looking like. So you can see here, it's, well, exactly as that example was at the bottom of the source folder. It's just ripped out all the actual text and chucked into a CSV file for us. And so whenever I'm coding this, I obviously have this up beside me just to keep me sane. And if I go back to my FFilterExtension here, so we're back into our source code. So we've converted it, that's all good, and then we grab that converted XLS file and just chuck it into an archive folder. One thing I always do is delete the destination file name if it exists. It often never will, but once in a while something will happen and it'll get into a weird state. I always code to think that it could be in any state, so I always ensure that if I am moving a file in, I just make sure there's no destination file there in case, and typically if you're coding, it might have already copied in, and then you break out and you rerun the program, and then you get back into it again and off you go. So I always code to make sure that it could be left in any state. Programs can crash and all the rest of it. So we move our Excel file into our archive folder, and we've got an exception, probably because it's opened. So the process cannot access the file because it's been used by another process. And so then we'll bail out here. So this is a good example. So this returns false. And then ultimately, that means we'll get if I bring up this here, you can see there's an exception thrown on the command line. And if I bring up this here, I'll just carry on running this. And if I bring up the log file, we can see, yep, so we've got our exception here. And so this is useful stuff here. It says we're archiving this, and then process cannot access it. So that gives us stuff to work on. Okay, so I'm going to close our Excel file and run this again. Convert our file. That worked. And so now we're just going to read it in. So this is where you'll spend most of your time. And again, this is good because it's a fairly simple example. So we create a new data table using the format that we want, which is date, time, load act. So that's our standard columns for any load act table in our database. I assume you guys have seen a few of these load act and load forecast tables and what have you.
Yes.
Yeah, cool. And so we create our data table to chuck all the data into. We have a look at all our converted CSV files. In this case, of course, it's just going to be the one. And then in this instance, I've found that it's more reliable to get the date from the file name than from the file itself. Now, this is a very specific instance. Our Indian clients always keep us on our toes. A lot of our clients always keep us on our toes, but the Indian guys always seem to find a way to tweak and change things, okay? And I found that quite often they will just, because these files aren't automatically produced, they're produced by a person, you get the human error all the time. And I've just noted over time that the timestamp in the file name is more reliable than the timestamp in the file itself in that column. So I actually ignore that in this instance. I normally wouldn't. And in fact, when I first wrote this, of course, I used the date that was in the file. But like I say, I found it better to extract and use the date from the file name. So that's what this part does. And then there's another useful method in the Tesla lib DLL, read in CSV. So all I do is pass in a file name, and then it just dumps it straight out into a data table. And so if I open up this data table object, you can see this is just a data table version of the CSV file. So that makes life now quite easy because we're just working on a data table rather than strings of data and things. Always do sanity checks on what you get back. And again, quite often, I will see, for example, the block columns missing. Once every month or so, they'll send us a file. The columns can be swapped around, columns can be missing, things like that. So no matter what the client is, always do sanity checks on your incoming file. Make sure that it is exactly what you expect. Exact number of columns, the columns are labeled correctly. And if they're not, spit out an error and bail so that we can see the errors in the log file, and always make the messages something that will enable anyone to go on. For example, if we don't have any rows in here, I always say the file and give the file name doesn't have any rows. If it doesn't have 4 columns, it says the file blah doesn't have 4 columns. It's much better to spell out what file you're talking about as well, because quite often you look at the log file and you say, oh, the file doesn't have enough columns. It's like, what file? And then you've got to sort of just spend a little bit longer just to go through and say, oh, yes, it's tracing through, it's reading this, okay. But I always love messages which really spell things out. So we do our sanity checks. We do a few more. Columns okay. So again, this goes through and goes through and checks all the column names. So for example, this next column, the second column, has got to be called time slot, and if it's not, throw an exception. The next one's got to be called block, and if it's not, throw an exception which gets caught and logged. And again, the last one's got to be called load. If it's not, bail. I have to say, I'll stress again, always do these sanity checks, because clients will find ways of screwing you over. And then if all of a sudden your fourth column is actually your block, then you're going to be starting to read, if you didn't care, if you just always said, right, I'm always going to assume the fourth column is my load data, and then all of a sudden they swapped it around, and then all of a sudden your load data just goes 1, 2, 3, 4, 5, 6, 7, 8, 9, that doesn't help anyone. And sometimes these sort of things can be far more insidious, and quite often, for some more complex files, you could be reading it. They might send us load for a whole lot of different regions in one file, for example, and you can imagine if we're reading in the load for one region and putting it into a table labeled for another region, how sometimes that could fly under the radar, right? And so that can really stuff us up. So spend most of your time just making sure the file is in exactly the right format that it has been specified, and assume at any time that it can change, because it will get you one day. So now that we've made sure that our file is exactly what we've expected, and we'll bail and output sensible log messages if it's not, we then go through each one of the rows and of course just suck out the information that we want. So in this case, we skip rows at the beginning that don't have any values on them, and then, like I say, we just go through, we do our sort of sensible things. We create our date time objects. We suck out our load value, and if it's empty, we make it -99, which is our, for better or worse, the Tesla's missing number, or missing number. We obviously, -99 can be legitimate values for certain things. So -99 was an unfortunate decision, but it was made about 30, 40 years ago when every byte mattered. And yeah, so for better or worse, -99 is our missing value code in our tables. So if we have any blank load values come in, we set it to -99. And then, of course, once we've written in our date and our load act value, we populate our date, time, and load act values and add that to our overall table. And then we just keep iterating until we've built up our converted table. And so that's this one here. So here we are, we're in our standard format, ready to chuck into the database. This happens to do one more thing. Again, sometimes I've seen our Indian friends send us a file, and the whole last third of the file might just be, it might be populated to 96 rows, but they don't have all 96 load values. So rather than populate the end of the load act table with a bunch of missing values, I'd use this, again, handy little method in Tesla lib, which goes through and it strips off any rows that just have -99 for the load act or what have you. And then once that's all done, this one actually calls the put table data on DB access rather than put table data in the inherited class. Oops, but we chuck it in the database, we archive off the CSV file, and we're done. So that's kind of a basic overview of what this class does. And if we bail out here, we can just see the rest of the code. All it does is just say, I'm done now, and return the overall result, which is 0 for success for an executable. And that's it, the code exits out. Yeah, so that's what FFilter does. And like I say, when you need to go about writing one of these yourself, you start by copying and pasting an existing one of these objects, something simple perhaps like this INBRPL, and yeah, go from there. Another thing, like if I go to this other one here, mysinglebuyer.cs, this is an example of one that actually downloads files from the web and parses them. So I thought I'd just quickly go over this one as well, because it shows you, how I sort of go about doing that. And again, if you need to pull a file from an HTML page rather than a CSV file from an FTP or something like that, great, I'd start by copying and pasting this object and changing it. And so again, we just have our read input method, and then what we do is we get our HTML page first. And so this is sort of the key difference. And here you can see how sort of simple it is to grab an HTML page. We've got if we have a look at our test already here, we specify the URL in there, and we also output what we download to a target file. Main reason for this is debugging. I mean, sure, we could download it in memory and then parse it and output it to a data table straight away, but quite often it's very handy to download to a file, because if something goes wrong, then you can look in the contents of that file, and that's of course something you can't do if it's only ever held in memory. So again, we get HTML page.
Any other quick question?
Yeah, sure.
So for isn't a filter extension mostly a reader program, and it should not be used for downloading stuff from web pages, or am I making this up?
Well, yeah, Jim might quite often say, don't use this for downloading HTML pages, use other things. But, quite often it is just much more of a mortal pain in the ass, to be perfectly honest. And the main reason Jim says that is because of, people would just download it to memory and then parse it, and then there's nothing left to debug.
Okay.
And quite often it is good to split out the download tasks and then do an update task.
Mm-hmm.
So you could create an object in here, and all it does is download, and then create another object, and all that does is read in the data from that download. So that would be a way of splitting them out.
Mm-hmm.
But
in this US office, we try to use the Tesla Wix was the old one. We try to use the Tesla Dynamo, which is the C# version of it that Steve rewrote.
Yep, and go ahead and carry on doing that. Nothing wrong with that whatsoever. In fact, that will make Jim a lot happier too.
Mm-hmm.
Okay, so definitely carry on doing that, and so you can ignore what I'm showing you here.
Well, we'll probably incorporate it into the Tesla downloader if it's already not in there.
Yeah, and this is an example of, it is very straightforward using the .NET framework to download stuff. You just make your HTTP web request object, and you get your response, you get your stream back, and you just pump that stream straight out to a file. Job done.
Mm-hmm.
So it's very easy in here. So that's what that does, and then of course it just goes in there, make sure the file's staying, pumps the HTML stream we got back to a text file here, and then obviously parses it and pumps it out to, extracts all the data, puts it into the standard data table object, and then puts it into the database just as we did. This uses a couple of little things in here, like in string utils extract between. I find this quite useful for ripping stuff out of the HTML files. So this just looks for the different parts of the HTML and says what's in between these bits of text is the stuff that I want. So there's a couple of little utilities in there, like that string utils extract between, that I use for HTML table or HTML file parsing. And again, we just call put table. This one correctly calls put table data on the constructor and chucks it all out. But yeah, so that's what FFilterExtension does. At the end of the day, it's very simple. There's obviously a lot of files in here, but that's because that makes our life simple. It's split out for every different type code that's read in. So the type code is the key part under any tag. That's what decides which one of these is going to be read in, essentially. And then you've got a few other standard things like, data table 1 for where things are going out, and source file 1 if it's reading in a source file. Yeah, so there any sort of questions about FFilterExtension?
No, I think the filter extension is the one application we're probably most familiar with.
Yeah.
Same here.
Yeah, okay. So again, like I say, the key thing to look in there is what's in the import base object if you haven't already, and yeah, just go for it. So yeah, I mean, if you're already quite familiar with your filter extension and you don't have any more sort of queries about it, then I'll probably leave it like that for today.
Question, I don't know if it's related to their filter, but can we, and then maybe I missed it in a prior walkthrough, but what exactly does Tesla control do?
So Tesla control, actually, hold on one sec, I'll just be back in 1 sec. I've got to turn off the heater, it's getting quite warm here. Right, so Tesla control. So Tesla control, let me fire it up. There's kind of two parts to the Tesla service, as it were. So first, let's see, I just have to keep changing what I'm sharing here.
I have to do something with the service and checking the service, but I don't know much more.
Yeah, I'll go through Tesla control and what happens. So you guys would be most familiar with this Tesla control interface, right? Can you see that?
Yeah.
Yeah.
Yes.
Yeah, so this is similar to, say, Windows Task Scheduler, but it's obviously the Tesla specific version of that, where you can make events dependent on other things, and you change all your types to your executes and your solves and all that. So you guys are familiar with how that works?
Yeah.
Yes.
Yeah. So this is your front end, right? And all this is really doing is manipulating the data service 2 table. And are you guys familiar with that?
Yep.
Yes.
Yep. So that's all that Control Console 2 does. It just manipulates, and if I bring it
Oh, is it the same as Tesla control?
this Control Console 2, yeah, all that does is manipulate what's in the data service 2 table, essentially, okay? So even if you click on one of the tasks in Control Console and say, where are we? If I click on one of these tasks and run tasks now, all that's doing is putting a flag in that data service 2 table, and it's probably called run now equal true or something like that, okay? So that's all it does. It's just a GUI. It doesn't actually call any programs or do anything like that. It's just that data service 2 table manipulator. So the thing that does all the work, and if I go back perhaps to my Visual Studio here, and I'll just bring up Team Explorer, Source Control Explorer. So Tesla 40, Source 40. There's our Control Console 2 we're just looking at. But the real guts of what does all the work is Tesla Control 2, which is essentially just a wrapper for Tesla Control 2 lib. Okay? So if I open up the Tesla Control project, this is the one that this program, if I open up program.cs here, this is a thing that sits in the background running as a service thanks to the XYNT service, and I'll go over that in a minute. So this is just a command line program, and when it's run, all it does is set up a standard stuff, and it just loops by default 400 times, looking for tasks that need to be triggered, or tasks that need to be run.
Right.
So what we do here is we go into test and control run. So it sets up all its basic stuff. It refreshes, its own internal copy of the data service table, and then it loops, say 400 times, just processing jobs. Okay, and then it just sleeps for a second, or the number of seconds to sleep, and just does it all again. So it just goes around and around and around and around and bails out. And then the XYNT service that wraps this just restarts it again. And the reason we loop a finite number of times and then quit out is really because that's the ultimate sort of safety thing. If a memory leak or something did happen, if this program was left running for months and months on end, which hopefully you could code it to do, then perhaps after X number of weeks a memory leak somehow occurs or something like that. These things happen, and then it can fill up the computer's memory and of course crash the computer. So we've just done this by design, loop finite number of times, quit out, and then have it automatically restart again, because it kind of it's like the old have you turned it off and on again sort of thing. Quite often that'll fix a multitude of any things behind the scenes.
So do you think about next walkthrough we could walk more in detail on, through the test control and the XYNT service and everything that does the work in the background?
Yep, I'll go over all of those things for you now. So again, what we do here, process jobs, it just goes in here, and like I say, just essentially all that does is look for jobs that need to be run. Again, this is coded so that it could be in any state. Like there could have been tasks that are running and then the power dies to the computer, right? So the first thing I do is tidy up any running tasks. So tasks that in the data service table at least indicate that they're running, but they're actually not because, someone pulled the power out of the computer and plugged it back in again. So it does a bit of a sanity check here. It refreshes the data service table that's holding a memory if necessary, and then it gets a list of jobs that need to run, and it orders it in order of what needs to be run first, and then it just goes through and runs each specific task. So each specific task is obviously going to be specified by all the details that are in the data service 2 table. I don't think I really need to go into much more detail with what this does, because that sort of makes sense, right? It just looks at the data service table. When a task needs to be run, it does it as specified, in the details that are in that table. And of course, the Control Console 2 app is responsible for creating all those details and putting them into the data service 2 table itself. One thing that actually is worth pointing out is that all of the doing code is in this Tesla Control 2 lib, which is also what Control Console 2 uses as well. Like this task object here, when Control Console 2, when you go through the wizard and build up a task and hit save, what that's doing is creating one of these task objects from this library and populating it, and even asking the task object itself to save its details and everything. So both Tesla Control 2 and Control Console 2, they're essentially just GUIs. This is a command line GUI, of course, Tesla Control 2, and all of the doing code is in Tesla Control 2 lib, really. Okay. So Tesla Control 2 responsible for running the jobs, and Control Console 2 responsible for creating the jobs and allowing you and manipulating the jobs. Okay. And this library where all the doing code exists. So how does Tesla Control 2, seeing it's just a command line program, work? Like, if I run this right now, it's just going to bring up a command line prompt, which you can't see, of course, and tick there running. So the way this works, if I now bring up hold on, I might just change my screen resolution to make it a lot smaller. If I do this one here, this will be nice and small, and then I can just share my entire screen. Come on, what are you doing here? Share monitor 2. Okay, does that display okay for you?
Yeah, more or less.
Oh, hold on, it's just slipped back again. Keep changes, there we go. Okay, so that's an okay resolution for you?
Yeah.
It's good for me.
Yeah, that's good. Okay. So if I go into C Tesla programs folder, what we use to make this appear as a service is this here, XYNTService.exe. Okay. So if you Google XYNTService.exe, you'll see it all over the internet. Okay, it's a basic thing that's been around for donkey's years. You know, it's well proven code, something we really haven't had an issue with. Well, we may have the odd issue with it maybe once a year or something odd will happen, and it's a case of reboot the computer and everything's fine. But it's pretty damn rock solid. And it's actually a very simple little program, and to control it is very simple as well. If I open up this XYNTService ini file, this is what makes this appear as a service. Okay, so it all kind of makes sense. Like service name, Tesla service. So that means in services.msc, that'll be the name here, Tesla service, right? So that's the name you specify there. So when you're running multiple Tesla installs on a machine, like maybe I'll have C:\Tesla India client 1, then I would call this Tesla India client 1 service, right? And so that means Tesla India service 1 will appear in here.
I think there's an issue, Tony, with the install. When we're creating an install package, it generates a service name like Tesla service, but not a specific client service one, even though we've specified it. Yep. Jim says it's a bug. Where would we go to fix it? I guess that would be somewhere in the install package.
Okay, so you ran the install and the services come up as Tesla service.
That's correct.
And you want to get rid of that. You want it to you want it to be called Tesla India Client 1 service instead, right?
Yeah.
Okay, so this is actually straightforward if you know how. So the trick, so when you run the install, it'll register, it'll run the XYNTService and put whatever's in here into the registry, and it's actually not what you want, right? So if I change this back to Tesla service and save it, and I go into my C Tesla programs here. So right now we see we've got Tesla service here, right? To get rid of it, if this XYNTService has our name here called Tesla service, I just go XYNTService.exe space -i for space -u for uninstall. I press return, I go back here, refresh, and it's gone.
But is it possible to make it work from the first time around? Because I mean, I know the trick with -u -i, but
oh yeah. I guess we could do the install so that it doesn't do the XYNTService -i. But honestly, once you know the trick, it might be better that the first thing you do is go in and do XYNTService -u to uninstall it. Change the XYNTService.ini file to whatever you want it to actually be. In this case,
but the service.ini, I mean, that gets created in the install process, correct?
Yeah, it does. It actually might be part of. If I go into Tesla Dev, delivery files client apps. Is it in here? I'm just wondering if it is or not. Delivery files data service. So if we go into this here, yeah. So this is what is put in place. So I guess it's conceivable where we could extend the install so that it says what name of the test service do you want to use, and we could replace a tag, like for example this target dir tag is replaced by the install itself with like C Tesla programs or C Tesla India client or whatever. So it is conceivable I could change the install so you can specify the service name. That would probably be a good thing for me to do actually. But until then, once the install's run, you want to do the XYNTService -u, then change this here to what you want and then reinstall it. And so I guess you're actually familiar with this XYNTService.ini file. I mean, the rest of it all makes real obvious sense as well. You never change the user interface or restart. You always want them set to what they are. And these are populated by the install. It's really just a service name you just change. But that's how you get rid of the bogus Tesla service that's sitting in there. You'd go in here, change that, do the uninstall, and then you change it back to what you want.
So do we have any the original code for the XYNTService.exe, or is that just open source and you can get it anywhere?
It is open source and it's probably in here somewhere. It's probably in the utils folder. It's not in here. It's probably let's have a look. I'm sure the source code will definitely be available on the web. Yeah, it doesn't look like we've recorded it in the source code in ours at all. I've just obviously grabbed the executable, the compiled one, and we've just been using that forever and a day.
So there's no source code,
huh? Not in there. But if I have a look on GitHub or something like that, well, that's annoying. Looks like my internet is down for some. Oh no, there we go. So here we are. Here it is in GitHub. And you see how old this is. But you can also see the rating. So here's the source code here for XYNTService. This is probably where I originally got it from. But of course it's also on GitHub. So that's where you can get the code. And so yeah, like I say, I've kind of resisted actually making the Tesla Control 2 a native service, because the whole idea of having it run for say 400 loops or whatever, put out and be automatically restarted, has proven itself to be extremely robust over the years. You know, we've never had issues with memory leaks and things like that, and I think that's in part because of the decision made way back when to do that sort of style. So we've just stuck with it.
Okay.
That's why we still use it. Yeah. So any other questions?
Nope.
None for me.
Okay, cool. Well, we'll probably leave it at that for today. So I've probably just gone over stuff you've already known by the sounds of it.
It never hurts. I didn't know about the CSV method, and I had to insert a method by myself. I'm glad we showed it.
Yep. But yeah, okay, cool. Well, we'll leave it at that, and I'll leave you guys to enjoy your evening.
All right. Thank you, Tony.
Cool.
All right, thanks, Tony.
All right then. See you later.
Bye.
Bye.